Today's fun fact is propagation delay. Propagation delay is familiar to anyone who's driven on an expressway during rush hour. If 500 cars are proceeding bumper to bumper and the first car stops, all the other cars will stop as well. When the first driver puts his foot back on the accelerator, the driver in the second car sees the brake lights ahead of them, and they go off, and he in turn switches his foot from the brake to the accelerator. The switching action is then relayed down the line of traffic. Even if each driver has a switching time from brake to accelerator of just 1 second, the last car in line will have to wait 500 seconds, or about 8.5 minutes, because of the propagation delay down the line. In the most high-powered computers, the switching time is 1 nanosecond, that is 1/1000th of a second. By those standards, a pocket calculator is relatively slow. Its switches each take about 100 nanoseconds to go from on to off. Another way to say that is each switch can go from on to off, or binary 1 to binary 0, about 10 million times each second. There are some calculator operations that require 10 million separate steps. If you ask your calculator to take the cube root of a 4-digit number, you'll see a blank screen for a second or so while the circuit works step by step through the math. Most problems take fewer steps though. Once the computation time gets down to below a quarter second or so, which is around 2.5 million steps, the operation looks instantaneous to the human eye. To implement the digital math and logic in practical ways, you'll need a switch that is small, reliable, power efficient, and fast. The device that meets all that criteria is a tiny piece of silicon called a transistor. It's a switch that responds to an incoming electronic pulse by turning, depending upon how it's wired, either on or off. When William Shockley, John Bardeen, and Walter Brattain invented the transistor in 1947, the groundwork was laid for the modern digital computer. A decade later, when Jack Kilby and Robert Noyce invented the integrated circuit, with thousands of transistors and other electronic components integrated onto a single piece of silicon, all of the clocks and games and calculators and computers we know today became possible.